be my first step to simplify number 1. Distribute, right? So what am I distributing in the first one? 3. And what would I distribute in the second one? -4. Perfect. Okay. So what is 3 times x? 3x. What is 3 times 3? 9. -4 times 5x? -20x. And -4 and a +7? -28. Good. All right, now we can combine like terms. 3x and -20x is -17x. And then a +9 and a -28. -19. Good. Now, can I combine -17x and -19? No. Will I solve for x? No. We do not have an equal sign, right? Or an equation. Yeah. So this is my simplified version here. Okay. All right. Number 2. What are we going to do with those parentheses? What do you think we're going to do with those parentheses? Okay, so I heard distribute the exponent. Liam, what were you going to say? Distribute the exponent? Anyone else? Okay, yeah, we're distributing. The only thing you have to remember is when we take 3, we're not just taking 3 times 2. That means 3 what? Squared, right? We're actually having 3 squared. Then we can distribute it to the exponents. And distribute means we do what with those exponents? Multiply. So what is 4 times 2? 8. And then y, what's 2 times 3? 6. Good. All right, next one. We have 2xy all to the 4th power. So that's going to be 2 to the 4th power, x to the 4th power, and y to the 4th power, right? Now, what do you think we're going to do here? Huh? I heard something. Multiply, right? And when we multiply, group them together. But let's go ahead and do our coefficients first. What is 3 squared? 9. What is 2 to the 4th? 16. So can I put 9 times 16 together? Yes. Okay. X to the 8th and x to the 4th. And then we have y to the 6th and y to the 4th. All right. What is 9 times 16? 144. What do we do with x to the 8th times x to the 4th? What do we do with those exponents? Add them. Yep. So we get x to the 12th. And then y to the 6th and y to the 4th is y to the 10th. Good. And is there anything else we can do? Nope. That would be your final answer. Okay. Any questions with that? Okay. Now, 3 is about the same thing. The only difference is what now? We have a plus sign in the middle, right? So after we distribute the exponent, then we can see, are they like terms to be able to add, right? If they're not like terms, will we be able to add them? Nope. All right, so we're going to have 2 to the what power? Second, maybe. 2 to the 2nd, x to the 8th, y to the 4th, plus 5 to the 4th, x to the 8th, y to the 4th. Good. All right. Now, what is 2 to the 4th? Or sorry, 2 squared. 4, I kind of said the answer there. X to the 8th, y to the 4th, plus. Now, 5 to the 4th, what's 25 times 5? 25. What's 5 times 5? 25 quarters is how much? 625, good. X to the 8th, y to the 8th. Now, are these like terms? Yes, they are. So can we combine those? Yes. Yes, we can. So what is 4x to the 8th, y to the 4th, plus 625, x to the 8th, y to the 4th? Yep. Good. 629, x to the 8th, y to the 4th. And you can see why I accidentally switched that one right there. I don't know why. There you go. And that would be your final answer. Any questions with that? Now, 4.5 is just multiplying polynomials by monomials. We've already technically done that. So we're going to use the distributive property. The only difference is, if you notice on the outside, instead of just distributing a number, we're distributing variables. So when we distribute variables, what do we have to make sure we do with those exponents? If we're multiplying, we add the exponents. We got to make sure we add the exponents, right? Okay. So go ahead and go through this. X times x. X squared. X times 3. 3x. Are these like terms? No, you're done. Let's do C. What's a negative 2x times 4x squared? So negative 2 times 4 is negative 8. What's x times x squared? How many do we have in total? X to the 3rd. Good. All right, what is a negative times a negative? Positive. 2 times 3 is 6. And what's x times x? X squared. Good. And then negative 2x times 5. So a positive times a negative is a negative. And what's 2 times 5? 10. And we have only one x. There you go. Do we have any like terms? No. So that would be your final answer there. All right, let's do D. Okay, let's do D first. Okay, so I'm going to distribute a 2x, and then we're also going to distribute a positive x. Yeah. So what's 2x times x? 2x squared. 2x times a negative 3. 6x, good. And then we're going to do the x. What's x times 5? 5x, positive. And what's a positive x times a negative x? Negative x squared, right? Because there's 2 x's there. Told you my computer is not working for me. Now, for this one, do we have like terms? Yeah. We have a 2x squared and a negative x squared, right? So 2x squared minus 1x squared would be x squared, good. And then we have a negative 6x and a positive 5x. So negative 6 plus 5 is negative 1, but we just have the x. Can we combine those? Nope, so you are done. Now B, we have a lovely one where it says 5xy squared and we're distributing it through, right? So if we look at 5xy squared times 3x squared, okay, that's that first term. Can we do 5 times 3? Yes, and what's 5 times 3? 15. What is x times x squared? How many total x's do we have here? 3, so it'd be x cubed. And then we just have a y squared, don't we? Any questions with that one? Now we're going to take that 5x y times a negative 4xy. Sorry, 5x squared, 5xy squared, okay? So what is 5 times that negative 4? 5 times the negative 4 is negative 20. X times x is x squared, because there's 2 of them. Y squared times y becomes y to the 3rd. Good. All right, and then we have 5xy times y squared. Well, we just have 1 5, right? We have 1x. Now, y squared times y squared is y to the 4th, right? Now, as you look at that, no, I kind of ran out of room here. But if I look at this here, do we have any like terms? Do we have any that have x cubed y squared up there? No. Do we have any x squared y cubes? No. Do we have any x y to the 4th? Nope. So this is simplest form there, and you can't go any farther. Okay. Hey, example 2, what's different with example 2? We're solving now. So same idea, but the only difference now is we have equal signs. So now we actually have to get it to what n equals or x equals or what y equals, okay? So again, we're solving equations. What is the first step to solve any equation? Distribute. So n times 2 is 2n. N times negative 5n? Negative 5n squared, is that correct? Yep. All right, and then we're going to do a positive 5. So positive 5 times n squared is, good. Positive 5 times a negative 2? Negative 10 equals 0. All right. Now, I'm not going to worry about the equals 0 first. Let's combine like terms. Do we have any like terms on the left side? Yeah, we have this negative 5n squared and the positive 5n squared. What's a negative 5 plus 5? 0. So do we even have that n squared anymore? No. So we just have 2n minus 10 equals 0. And now what would I do? Add the 10. So we have 0 plus 10 is 10 equals 2n. And then what? Divide by 2. So n would equal 5. Go ahead and do C on your own real quick. Go ahead and do C on your own. All righty. So what did you distribute? The 3, right? What's 3 times z? 3z. 3 times 3? 9. Minus 7 equals 8. So I'm going to leave the 8 alone. We have 9 minus 7. And what is 9 minus 7? 2. So then how do I move that 2 to the other side? Subtract it. So 3z equals 6. Then Divide by 3, so z is 2. Good. All right, b, what are we distributing in b? The y and 3. What's y times 2? Y, good. What's y times negative 3y? Good, negative 3y squared. What's 3 times y squared? Good, 3y squared. 3 times negative 4? Equals 0. Good. Now, we do have like terms again. What's negative 3y squared plus 3y squared? 0, so I'm left with 2y minus 12 equals 0. So how do we solve for y? Add 12. So 2y equals, bless you, 12, and then what? Divide by 2, so y equals 6. Good. All right. Now D. Do you guys like D? Yeah? Okay. A lot of people say they don't like D because of fractions, which I understand a little bit, okay? But when we're, I don't know why that's not moving, but when we're distributing fractions, remember, we multiply by the numerator, and what do you do with the denominator? So we multiply by the numerator, and then we divide by the denominator, right? So what's 1 times 6c? 6c divided by 2 would be 3. 1 times 4? 4 divided by 2 is 2. Good. What is negative 2 times c? Negative 2c, good. A negative 2 times 5? Negative 10, and negative 10 divided by 2? Negative 5, good. And then we have 2/3 now. 2 times 9? 18. 18 divided by 3? 6. 2 times 3c, negative 3c, sorry. Negative 6c, and negative 6 divided by 3? Negative 2c, good. So I think that's the easiest way to think of fractions. Multiply by the numerator, divide by the denominator. Okay, now do we have like terms on the same side? Yeah. What is 3c minus 2c? C. What is a positive 2 and a negative 5? Negative 3, good. And then we have that 6 minus 2c. Now we still need to combine, that's a c. We still need to combine this c and this c. But now, are they on the same side? No. So do you want to move the regular c or the negative c? Negative. And how would I move a negative c to the other side? I would add it. Good. There's a c at the end there over here. I don't know why it's not showing up. What's 1c plus 2c? 3c minus 3 equals 6, because those cancel. Now, how do we keep going? Add 3. So we get 3c equals 9. And then what? And then c equals 3. Divide by 3. We got 3. C equals 3 there. My computer has been messing up the last 2 days. I don't know. So sorry. Okay. Any questions with that? That's what 4.5 is. Not too bad. No. All right. Let's go ahead and go into multiplying polynomials. Okay. Now go ahead and do questions 1 and 2 here for me. I don't work on questions 1 and 2. So 1 is like we did, I think, back in 4.1 or 4.2. And then 2 is just what we did, okay? I'll go get a drink of water or something. Make sure, walk around for a second. Okay. Was it a rough day yesterday? Long. Okay. Because normally you're tired, but not this tired. All right, number one, what are we doing here? We're just adding, right? So we need like terms, right? So x squared can be added with negative x squared. What happens to those? They cancel, don't they? 4x can be added with 8x. And what is 4x plus 8x? 12x, good. And then we have a negative 7 and a negative 10, which makes negative 17, good. Okay. Can we combine 12x and negative 17? Nope, so that's your final answer, okay? Number two, what are we doing here? Distributing. So what's 2x times 6x? 12x what? Squared, good. What's 2x times a negative x? Negative 2x to the third, good. What's 2x times 1? 2x, good. Now, negative 3x times 12. Negative 3x times 12. Negative 36x, good. Negative 3x times x. Negative 3x squared, good. And then negative 3x times a negative 3x squared. Positive 9x to what? Cube, third power, good. All right, let's combine like terms now. 12x squared and negative 3x squared, right? And what do we get? 9x squared. Okay. What is a negative 2x cubed and a positive 9x cubed? 7x cubed. Now, where should I put 7x cubed? Should I put it after 9x squared or before it? Before it. Why? Standard form. Good. It has a bigger exponent. Good. And then what is 2x minus 36x? Negative 34x. Good. All right. All right. Any questions with that? Now, what we're doing is before we multiply monomials to polynomials, right? Now we're going to be multiplying binomials, okay? And what are binomials again? Two terms, right? Two terms. There are multiple ways to do it, okay? The first way is we're going to use the distributive property. Okay, we're going to use the distributive property, okay? To use the distributive property, okay? All right, what we do is we break apart the first one. I'm going to take x, and I'm going to take plus 3. Okay, break apart the first one. And then I'm going to set the x plus 2 next to each of these. So now does it look like what we just did where we multiply monomial by a polynomial? Yeah. So what is x times x? X squared, thank you. X times 2? I know, 2x. And then we do the 3. What's 3 times x? 3x. And what's 3 times 2? 6. And now, do we have any like terms here? Yeah, we have the 2x and the 3x, which makes 5x. So we have x squared plus 5x plus 6. And there you go. That is your final answer. Okay. And that is using the distributive property. Now, I say break apart the first one, but does it really matter which one you break apart? No, it doesn't. okay? So if I'm looking at 5x minus 3 times x plus 1, which one do you want to break apart? X plus 1. I would do that also. It doesn't matter. So what parenthesis goes behind it? 5x minus 3. All right, so now go ahead and multiply that for me. So x times 5x was 5x squared, good. X times negative 3. And the nice thing, 1 times everything is just going to stay the same. All right, let's combine like terms. 5x squared, do we have anything alike? Nope, so we're going to leave 5x squared. Maybe. Negative 3x plus 5x is 2x, good. And then we have minus 3. And there you go. And there's your final answer. Okay. All right, that's the distributive property. The next way we're going to learn is by using a table. Do you guys remember the multiplication table that you guys have? Like when you multiply back, when you learned how to multiply, you saw that multiplication table? That's kind of like this, all right? The difference isn't just numbers. It's got letters now, okay? So let me scroll down somehow. Nope, that's not how. That's all right. We'll make it work. All right. So since this is a 2 by 2, okay, I'm going to draw a 2 by 2 table. Okay. So I'm going to put my first binomial on the left side. So I got x and I have negative 5. Okay. And then I'm going to take the second one and either put it up top or in the bottom. It doesn't matter. So x and positive 4. Now, do we understand how a multiplication table works? So to get this first table or first box, what do I multiply? I multiply x and x. So what's x times x? X squared. All right. To get this one here to the right of it, what would I multiply? X and 4. And what's x times 4? 4x. To get this one here, I would multiply what? To get this one here, I'm multiplying negative 5 and x. And what's negative 5 times x? Negative 5x. And to get the last one, what would I multiply? Negative 5 and 4, and I get negative 20. All right. So now let's combine like terms. X squared. Blue box, is there anything that I like with it? Nope, so I leave it. 4x and negative 5x, so the yellow and green make negative x, yep. And then we have negative 20. And there's your answer. All right, 4, we have a trinomial times a binomial. So instead of a 2 by 2, I need to have a 3 by 2, right? A 3 by 2 or a 2 by 3. Doesn't matter how you work it, okay? So I'm going to go, because of my spacing, I'm going to go 2 that way and then 3 this way. Okay. All right. So obviously I have 2 here, so I'm going to put my binomial on the side. So I have x and I have negative 4. And then my trinomial I'll put across the top. So I have x squared. What else? 2x. And I have a positive 6. Okay. All right. Now to get this box, the first box, I'm going to multiply what 2 things? X and x squared. So what's x times x squared? X cubed, yeah. The next one, I'm going to take the x and times it by the 2x, right? So this box would be x times 2x. And what's x times 2x? 2x squared. And then the last box, I'm going to take x times 6, right? X times 6. And what is x times 6? I don't know. I'm going to have to do that one. 6x. Okay. So then the bottom, I'm going to take now -4 times each one of the tops, right? So what's -4 times x squared? -4x squared. -4 times 2x. -8x, good. And then -4 and a +6. -24. And now can we find our like terms and combine them? Yep. So x cubed, can I write with anything? Or combine with anything? Nope, so it stays. What about 2x squared is alike with what? -4x squared. And what's 2x squared minus 4x squared? -2x squared. And then 6x and -8x is -2x. And then we have minus 24. And there you go. Now, do you think I care which method you use? I do not. Okay, so if you like the distributive property or if you like using the table, that is 100% up to you. Okay, those both can be used by binomials times a binomial, binomial times trinomials. Okay, now, foiling? Yeah, that's what we're gonna do now. Now, the next method can only be used for binomials. Okay, this is the only one for binomials. Okay. So this FOIL that we're going to learn here, maybe in a second when I can scroll up somehow. I don't know what is going on. All right. All right. So this one can only be used with binomials. It's called FOIL. Okay. FOIL is exactly like the distributive property, actually. Okay. And FOIL means I'm going to multiply the first terms of each binomial. So the first terms. So if I'm looking at this 2x plus 1 and the 3x minus 5, what are my first terms of each one? 2x and 3x. So what's 2x times 3x? 6x squared. Yep. The O is our outer terms. So the farthest ones apart. So what are the farthest ones apart? 2x and -5. So what is 2x times -5? -10x. You see how that's kind of like the distributive? I take 2x and I multiply by everything in the other one? Yeah. So what do you think I is going to stand for? Inside or inner? Yeah. You guys could say outside, inside, it doesn't matter. Are you throwing things? Yeah. All right, so inner, and what are my inners? 1 and 3x. So what's 1 times 3x? 3x. That's a plus sign. And then L is my last terms. And then terms. Okay, so my last ones are 1 and -5. And what's 1 times -5? 5. So we have 6x squared. What's -10x plus 3x? -7x. And then we have -5. That would be your final answer. Okay. Right. So let's do the 9x squared, or excuse me, 9x minus 2 times x plus 1. Okay. So what are my first terms? 9x and x. So what's 9x times x? 9x squared, good. What are my outer terms? 9x and 1. And what's 9x times 1? 9x. Inner. What are my innermost? Negative 2 and x, which is negative 2x. And then last terms. What are my last two? Negative 2 and 1. And we get negative 2. So we have 9x squared. What's 9x minus 2? X. 7x. And then we have minus 2. And then you're done. 9 times out of 10, guys, if you're multiplying binomials times binomial, you're always going to end up with a trinomial. 9 times out of 10. Okay? All right. Any questions so far? So again, do you think I care what method you guys use? No, I really don't. I'm not going to show you another one. These are the 3 that I want to go over. So FOIL can only be used with what? Binomials. Then distributive property and the table can be used for either binomials and binomials, binomials and trinomials, binomials and polynomials, whatever, okay? The table and the distributive property can be used for anything. FOIL can only be used with binomials, okay? So real quick, I want you guys actually to do just example your turn 1 and 3, and then we will be done. Actually, let's do that 1 and 3. Yeah, 1 and 3 is fine. Do 1 and 3, and then we'll be done. Well, I erase this if I can. And again, I don't care what method you use. That's 100% up to you. I'm not a teacher that says you have to do it a certain way. As long as I can follow your work and see if you make a mistake, what you did wrong, okay? And then, Abby, if you feel comfortable, if you just wanted to go ahead and pop off so you could take your quiz, you're more than welcome to, okay? Because I know we're getting close to the end of the block. Unless you don't feel comfortable with this, we can worry about another time, okay? Okay, you too, Abby. For your binomials, which way are you guys doing? FOIL? You like the table? Yeah, Allie, what do you like? FOIL. Leah, FOIL? Table? Okay. Yeah, and like I said, it doesn't really matter at all, as long as I can see. The only thing with the table, sometimes it gets tedious, constantly drawn. Ooh, number 3, if you look, I forgot an X in there, didn't I? Did you guys treat that as 10X or did you treat it as 10? 10? Okay, good. Okay. There's supposed to be an X in there, but that's all right. So I probably would have simplified that one first before I actually multiplied. Did someone do it as an X? No, no one did. I thought someone did. Okay. Huh? There isn't one. I was just wondering because it was supposed to be a trinomial. So. My mistakes. This is why you always proofread things, guys. All right. So if we did, I'll do one of each. So if we FOILed the first terms, 3x and 3x. 9x squared. That's an X. Outer, 3x and negative 10. negative 30x. Good. Inner, 10 and 3x. Positive 30x. And 10, last terms, 10 and negative 10. Negative 100. What happens to my inside and outside terms? They cancel out. So you know how I said 9 times out of 10 you end up with a trinomial? This is the one time you don't. What can you tell from these two? What can you tell about those two binomials, Tori? Yeah, they're the exact same except one is positive and one is negative. These are known as conjugates or difference of squares, okay? Those inside and outside terms will always cancel out in these types of problems. Yeah. Yes, yep, exactly. It is. If you notice that right off the bat, those are going to cancel out. That's fine. Now, if those are both plus signs, what changes? If these were both plus signs, this would be 60x, and this would be a positive 100. Okay, you know. All right, the next one over here, let's go ahead and simplify. What's negative 10 minus 4? No. Negative 14, right? All right. So now someone said, let's do the table. They like doing the table, so we'll do that. We have a 2 by 2, right? So what do you want on this side here? X and negative 5, okay? And then on the top, 2x squared and negative 14. All right. So my first one, oh, that was not what it was supposed to be, but there we go. 2x squared times x. 2x to the third. Good. Over here, we're taking x and negative 14 is negative 14x. Down here, we have a negative 5 and 2x squared is negative 10x squared. Good. And then a negative 5 and a negative 14 is a positive, big number, not that big, 70, right? Yeah. Now, do we have any like terms here? No, we don't. So we don't have to combine anything. We just have to list it in standard form. So what would go first? 2x to the third, then minus 10x squared, minus 14x, and then plus 70. And there you go. Okay. All right. Any questions with this? You guys feel okay?